All right, so these type of angles are also on the circle intersections. Basically, we've done some on the circle angles before. If you'll remember, we had inscribed angles. And the only difference is those inscribed angles, both of the sides of the angle were what we call chords or secants. But right here, notice that I have a tangent line as one of the sides of my angle. So if I'm looking at angle 1 right here, it's got a secant line as one of my sides and it has a tangent line. So that's really the only difference, but the formula is the exact same. So if you'll remember from our inscribed angles, our angle was half what the arc is. This is going to be the same thing. So this angle 1 is going to be half of what we call the intercepted arc. So all we have to remember, though, is that our intercepted arc, instead of going from the end points, it goes from the end point of the secant, but our tangent only touches one place. So it's going to go the arc that's clear to the point of tangency, where our tangent line touched right there. So it's just going to be half of that arc between A and B, measure of arc AB. So it's half of the measure of arc AB right there. Okay, same thing for our angle 2. Notice our angle 2, one of the sides of angle 2 is that secant line, but the other one goes that tangent line on the bottom. So again, if it's on the circle, it's going to be half. Just remember that half. These have all been halves, but it's going to be the intercepted arc that goes from that end point of that secant all the way around through the point of tangency. Now remember, if it's a major arc, you cannot call this one BA or AB because we've already got this AB up here. If you say AB, they're going to go to this one. So in order to name this intercepted arc right here, from point of tangency to the endpoint, don't call it AB, we're going to call it ACB or BCA, either one of those. So ACB is just going to have 3 points if it's that major arc. All right. So again, I don't think it's too new. I just think of it kind of as a type of, and as an inscribed angle right there. Okay, let's look at example 3. They're wanting us to find the measure of angle DEG. So here's D, here's E, here's G. Again, notice right there that point of tangency where our tangent line touches a circle, that's our vertex. So we've got a tangent as part of as one of our sides of our angle, and then we've got that secant line right there. So same thing, all you're going to do is you're going to take half of the intercepted arc. So this intercepted arc goes from that end point of the secant line clear around to the point of tangency, which they've told me is 308. So I know that that angle is equal to half of this arc. 1/2 times 308 degrees. Well, half of 308 degrees, 150 plus 4, so 154 degrees is that angle. And I told the class, the people in class, guys, this is a good unit to do some common sense checking on. If you kind of remember and mix up all these formulas, just look at that angle. Does it look like a 104-degree angle? It does. If you get it wrong, usually it's way wrong. Like if you times it by 2, you'll say it's a 616-degree angle. You can know that's absolutely wrong. So on these, when you mess up, it's usually a big mess up. So you'll be able to do a common sense check just to kind of look and say, yep, that looks like it's getting close to our straight angle, which was 180 degrees. Looks good to me. Okay. All right, this time I'm asked for an arc. So this time I needed the angle. This time they're wanting the arc, and they want the arc, let's look here, between X and Y. Notice it's a minor arc, just 2 letters. Here's point X, here's point Y. So they want that lovely arc right there. There's a couple ways to do this. In fact, I did it different than the class did. What I did is I looked at what we already knew. We knew this angle. So notice this angle is the angle that goes right here. This is WXY that they've given us. This is 151 degrees. So what I did is I took that angle and I found its intercepted arc. So I found the arc that goes from that point of tangency all the way around to that end point over here. Remember, the angle is just half the measure of its arc. So I'm going to multiply this by 2 to find this arc. So this arc is 302 degrees. That arc is 302 degrees. And then I'm just going to say, well, I know something about arcs. So I know that if I wrap all the way around the circle, I've got 360. So I'm just going to take away the rest of that arc that I don't want. So I'm just going to do 360, subtract 302. And my arc that I want between X and Y is going to be 58 degrees. Okay. The other class, excuse me, some of the other class decided that they wanted to find this angle that includes that arc, and that is just fine. Remember, these are a linear pair. Those two angles are a linear pair. So you could go ahead and just subtract that 151 from 180. You get 29 degrees right there. That angle is 29 degrees, so the arc is double that. Remember, arc is twice as big as that, and that'll give you the 58 degrees as well. All right, there were examples 3 and 4.